Welcome to this presentation brought to you by NYJavaSIG. You can follow us on Twitter, subscribe to our YouTube channel, visit our webpage, and please become a member of our group. Registration is absolutely free. This video contains excerpts from a workshop called Two-Factor Authentication, 2Furious. The presenter is Matthew Gilliard, a developer evangelist for Twilio.
Thank you, NYJavaSIG, for inviting me, and thank you everyone for attending. I'm really pleased to have this chance. I'm really grateful. What I'm going to do now quickly is share my screen. So if I click share, you can see that. And confusingly, it looks like a video of me on my screen until I switch over to my slides. So, like Barry said, I'm going to start with 30 minutes or so of talking about 2FA, what it is, how it works, why it's important, and then we'll go into the hands-on workshop phase. So without further ado, I will get cracking. How about that? My name's Matthew. I work for Twilio, and there will be like occasional mention of Twilio, but this talk is not at all about Twilio. It's about two-factor authentication. You've got my Twitter handle there. You've got my Twitch handle. Come and say hi, ask me anything, anytime. I'm always open to talk. Okay, so I'll start now. And I'm going to have to start with some bad news. I'm very sorry to do this to you, but the bad news is that there are bad people around. People who from the neck down might look reasonable, but check this guy out, like hunched over, balaclava. You can see he's up to no good. There's people like this guy. He's up to even less good. Balaclava again. This seems like, I'm sorry if you live in a cold place and you have to wear balaclava to keep warm, because it just makes you look like you're up to no good when you're using one with a computer. And I think the hammer's a giveaway as well. Sometimes these people get caught, but that doesn't stop them. This lady's managed to get a laptop into prison to do her hacking, and she's pretty cross that we've managed to sneak up behind her. And there are also people out there like this. And this is not a hacker. This is one of the many people who've had their lives like badly affected by nefarious activities online. This guy, perhaps you've heard of him or you know him. This person is called Matt Honan. And Matt, we know he's a tech journalist, and he wrote a very sort of comprehensive story of how he was hacked by, firstly, being hacked against his will, and then secondly, agreeing not to press charges against the hacker in exchange for like a frank interview about how it happened. So we know a lot about this, and I would like to go through this in detail, and we'll see about how two-factor authentication could have fitted into this story. Unfortunately, it doesn't. So let's start, right? Matt's a journalist. He's got a personal website on a custom domain, and he's got his Gmail address on there. That doesn't seem like a big deal. I do that. Why would that be a problem? Okay, so someone decides they want to pick on Matt. They find his Gmail address. They go to Gmail and they trigger the password reset flow. And the password reset flow for Gmail, back when this happened, and I'm not sure if it's still like this, is to send a password reset link to your backup or to his backup email address, but they don't show the full backup email address on the screen when they do this. They sort of redact some of it. So there's absolutely no way that you could guess what his backup email address is just from looking at this, right? Well, it's actually pretty obviously matthonan@me.com. It's also significant that it's me.com. We'll see why later. What next? They do whois on his domain name. So he's got this custom domain. I don't know if you know whois. It's a tool for querying DNS records. I have a domain name, Gilliard.lol. If you do a whois on this, you see domain name, it's registered with Gandhi, and then blah, 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 lots of details about Gandhi, and lots of stuff down the bottom that's redacted for privacy. Look at what it is that's redacted for privacy, right? Name, street, city, state, everything to do with where I live. And this redaction is optional and wasn't applied in the case of Matt Honan's domain. So these people, they now had his street address, his email address, his backup email address. What next? You probably didn't guess this, right? They're going to call up Amazon, back in the days when you could call up Amazon. And they asked Amazon over the phone, could we please add a credit card to Matt Honan, honest, my Amazon account? Amazon has some security questions, and the hackers don't know, you know, mother's maiden name, first pet's name, this kind of thing. But they eventually managed to convince Amazon that they were Matt Honan because they knew his email address and his billing address, which they found from whois, right? So this is the story of social engineering and of different sites and different mechanisms using different things to authenticate people. So they added a credit card to his account, probably a stolen one, but it seems like a nice thing to do because they might be, you know, buying some stuff for him. No, the story doesn't go that way, unfortunately. They hung up, and what next? They called Amazon again, and they asked for a password reset. And again, they couldn't answer the security questions, but again, they managed to convince the Amazon representative that they were Matt Honan because they knew his name, his billing address, and now they knew the last 4 digits of a credit card registered to his account. So that's why they added it in the first place. So they now had his Amazon account, you know, full access to it, actually. What next? Well, same kind of thing, social engineering, but this time against Apple. And we've got timestamps here from Matt, and it plays out very, very quickly. The whole of the rest of the story takes place in just a little over half an hour, excuse me. So Apple, their security protocols are ask the security questions. If that doesn't work, name, billing address, and the last 4 digits of a credit card. But a credit card that's not from Amazon, obviously, but from the Apple account. So how would the attackers know that? Well, to this day, if you log into an Amazon account, you can see the last 4 digits of all the credit cards that are associated. So let's pretend this one is the one that the hackers added. Then they can see the last 4 digits of Matt's real credit card. This is actually a screenshot of my Amazon account, just in case you're feeling generous. Okay, so they were able anyway to get an Apple ID password reset. And that's pretty significant because Apple ID lets you log into me.com. And the hackers knew this, and that's why they had targeted Apple in this way. So now they have access to the me.com email address that is the backup email address that is used in Gmail password reset flows. And obviously, Apple took 17 minutes to reset a password. Google did it in about 2. And then they wiped his iPhone, and they've got access now to his full Gmail account. Now, I don't know like how you would feel about the idea of someone having full access to your Gmail account, but it kind of strikes the fear into me. There's a lot in there, and I take the security of it very seriously. Using the Apple ID, they bricked his iPhone, so he's now got an expensive glass metal paperweight. Excuse me a sec. Okay. And now Matt knows, like, this is the first time Matt knows that something's up, right? Because his phone suddenly switched off and he's like, what's this? Botched over the air update, something's gone wrong, just crashed. Who knows? Won't turn back on, right? It's been reset and turned off by Apple. Excuse me. Next up, reset his Twitter password. The Twitter password flow was reset through having access to the Gmail account. And then a couple of minutes later, they wiped his MacBook. So Matt is now fully aware that something terrible is happening to him. They deleted his Gmail account. He can't do anything, right? His phone and computer are dead. His Gmail account's gone. He's like completely stuck. And throughout this, the only thing that Matt permanently lost were some family photos that were only stored on the MacBook. And he's kind of very mature and reasonable about this and just says, look, I could have backed those up. That isn't like entirely the hacker's fault. And also he says, you know, I wasn't using 2FA on any of these accounts. So I could have been taking my security better. He takes a very measured approach to it, which is commendable, I think. And then the last thing, and this I think is just the worst thing, even though it's kind of silly, the whole end game of this was just to post to Twitter as Matt, taking credit and then just posting some offensive crap to Twitter. And then that was it. He has a 3-letter Twitter handle at MAT, and they just thought they'd do it for fun because they could. So that's a bad story of what happened to Matt Honan. And it's a combination of social engineering, mismatched security practices between different companies. Apple actually claimed originally that their employee was not following Apple's practice.
एक हेडफोन तूने सेव करके रखे है ना? एक हेडफोन सेव करके रखे अपने पास? हाँ जी, वो जो चेस्ट में. दे दे. मैं उधर बैठने वाला हूँ.
Can I carry on?
तू लाइट रखे ना. Light on कर please दोनों.
I'm going to carry on. At no point during this did any of, I don't think that was a question for me, it was just some background noise. At no point during this flow did the attacker actually know any of Matt's passwords. They did a couple of password resets and were able to set their own passwords or generate new passwords, but they didn't know anything they didn't know any of his passwords. I see, yeah, request from the organizers to be on mute if you're listening. Thank you very much, that would be nice. So, okay, so they didn't know anything about his passwords, but they were still able to socially engineer and take advantage of different companies' different approaches to security here. We're going to have a quick talk now about passwords. This guy wants your passwords, right? 81% of all hacking-related breaches use stolen or weak passwords, right? Users are not good, people in general, not just users, humans are not good at password hygiene, right? You've heard this advice a lot. Use strong passwords, use different passwords on each account. And because of that, you're going to have to use a password manager. I'd be interested, if you want to type in chat, fire up your password manager now and just tell me how many accounts you've got in there. For me, it's around 290 at the moment. There's no way I could remember all those. I would have to use the same password over and over. There is a website called Have I Been Pwned? And I'm in my 40s and I struggle with the word pwned, but I'll push through. HaveIBeenPwned.com, which collects breached account details, usernames, email addresses, and passwords, and makes them public. So you can go to HaveIBeenPwned.com. I'll show you a link in a minute. And you can type in your email address and see how many times services which you have an account with have been breached. You can also type in your password and see how many times that has appeared. There might be other people with the same password as you, just by chance or because you've got a common password. I'm going to tell you a story about a person I know called Paul, who works for a company called Co-op Digital in the UK. Co-op Digital, if you're not aware, Cooperative Digital, they make services like financial services, store cards, funeral services, health insurance. It's not like trivial stuff. It's not cat pictures, although those are very important. So Paul says, Have I Been Pwned is such a good service. He's talking about the API for Have I Been Pwned in this. He said he hooked up password validation to Have I Been Pwned to protect co-op members. We see around 1/4 of people try to use a compromised password and then change to a safe one. And he really hopes they take this behavior to other sites. And I think that's a reasonable thing to hope for, you know, although all the evidence suggests that people won't. And there's an example here. Someone's trying to register, they put in a password and it says, choose a different password. The one you have entered appears in a list of hacked passwords. Okay, let me just move the mouse out so that gets away. Right, Paul goes on, when you reset your password, you can't choose a password in the pwn set, so they're just preventing it on password resets. But when you register, we started by just warning you so as to not impact conversion. We've since stopped letting folk use a compromised password on registration, and it's had no identifiable impact on conversion. So to me, that seems like a big win for the security of the data that Paul's users are entrusting him and his team to look after. I skipped over a sentence in the middle though. Between 1/3 and 1/4 of folk chose to use a compromised password anyway, right? So I just jump back here. Choose a different password. The one you have entered appears in a list of hacked passwords. Between 1/3 and 1/4 of folk chose to ignore that message, right? And this is well documented. It turns up again and again. And I think we have a huge obligation, like an ethical and sometimes legal, depending on exactly what industry you're in, obligation to our users. We can't, this is, you know, my kind of stance on this. We cannot just say, users, this is your problem, use good password hygiene. This is a problem that we have as an industry, and we're failing our users by not, you know, adhering to that kind of ethical standard that we should be setting to ourselves. So let's do better, please, myself included, everyone in the industry. This is our responsibility. Rant over. I'm going to lighten things up with a quiz. Everybody, you've got 20 seconds whilst I drink some water. What do you think are the most common passwords in the Have I Been Pwned data set? And please type them into the Zoom chat. Go for it. I'll wait for a couple more. All right, let's go. So imagine you were lazy and you put your finger somewhere and went like this. You would end up with a password something like this. And this is the top password in the data set. Now imagine you were 50% less lazy. You'd go 50% further. Now imagine you couldn't quite reach so far up the keyboard, right? You can see a pattern here. Of course, passwords in there, it would be ridiculous if it wasn't. Everyone knows that's a commonly used password. And the last one I found a little bit surprising because I actually find it a little bit difficult to type. You have to count in your head. 1, 2, 3, 4, but wait, was that 5 or 6? Well, okay. The point is, like, these passwords, in Have I Been Pwned, there are over 10 billion accounts, and these account for several million of them, tens of millions of them. It's unbelievable. It's not a responsible attitude to take as a software engineer to imagine that our users will use good password hygiene. I really believe that. Remember this list, there'll be a quiz later. Not really, well, only semi-joking. Okay, so let's get on to the meat of the topic, right? Two-factor authentication. Everyone knows what the number 2 is. I think you've got 2 of something, that's 2 of things. Everyone kind of understands authentication, but what are factors? This guy's got a balaclava and a hammer. Is that two-factor authentication? I'm not so sure that you'll agree that it is, and indeed it's not. Factors are identifying things that a user can do to identify themselves that come in different categories. So factors come in categories, and the common categories are knowledge factors, something you know, like a password, something you have, like a possession factor, that's called, something you are, possibly a biometric factor. These are called inherence factors. And so for a two-factor authentication, there have to be 2 types of information coming from a user from different types of factor. So username and password is 2 separate things, but they're both knowledge factors, so it doesn't count as 2FA. Very, very commonly for web services, you're going to have a knowledge factor and a possession factor. And this is nothing new. If you use an ATM and withdraw money, you need your card, a possession factor, and you need your PIN number, a knowledge factor. That is something that everyone who banks and uses ATMs is familiar with, and it's not a complicated concept if it's kind of explained clearly. So I don't think that shying away from doing this because users won't be able to understand it is really a responsible approach either. So what's the login flow to get into a website? How does this apply to the internet and the web services, which I think a lot of Java programmers are building? Normal login flow without 2FA, 2 knowledge factors, username and password. So for a 2FA flow, there's a second factor, a possession or an inherence factor. What kind of things are used as possession or inherence? And it's very commonly possession. And inherence we'll talk about a little bit later on, but it's very commonly a possession factor. And the possession in question is very commonly a smartphone or a telephone, a mobile phone of some kind. So SMS. When you register on a website, and I'm sure a lot of you have done this, you're sometimes asked to put in a phone number, and they will send you a code, and you type the code in, and then when you come to log in later, they will send another code to the same phone, and by that means they are trying to ensure that the possession you had, the phone, when you registered, is still a possession you have, and therefore you are the same person. You commonly get a 6-digit code, but it really could be anything. It's just something generated on the server that's difficult to guess, that comes to you by one means and your phone, and you type it in through the other means, the website. So pros and cons of SMS 2FA. SMS is ubiquitous. 7 billion people on the internet have, 7 billion people in the world more than have access to SMS, more than have access to the internet, more than have access to smartphones, certainly. The con that is often brought up against SMS, it's not totally secure. And it's true that law enforcement agencies, nation states, and in fact, anyone who's got a few $1,000s to spend on eBay can set up a fake base station, negotiate very weak levels of security between that base station and phones that register to it, and then get to work cracking. But importantly, SMS-based 2FA is significantly, massively more secure than not using 2FA at all. So don't be swayed by the argument that because there are theoretical and practical attacks against SMS security, that it's just not worth using. It's still tons better than not using 2FA at all. Moving on, and this is something that might look familiar to a lot of you as well. When you come to log into a website, you might have to use one of these apps. This is a screenshot of Google Authenticator. I tried to get a screenshot of the Authy app, and Authy has a security profile in Android that won't let you screenshot it. Authenticator doesn't. Anyway, these are called HOTP and TOTP. If you've ever grown up in the UK like I have, you might look at TOTP and think it stands for Top of the Pops, which was like a pop music program that was on TV a lot when I was a kid, but it's not. OTP in both cases is one-time password, hash-based one-time password, and time-based one-time password. HOTP is not widely used, but I will go into some detail about how it works as a stepping stone to explaining TOTP, which is widely used and is what you're looking at in the Google Authenticator app or the Authy app or the Okta app or the LastPass app or whichever one you use. And we'll see that actually it doesn't matter which one you use because they all work exactly the same and generate the same codes. So first thing to note, there is an RFC down here. I will share these slides later and there are links, or you can just Google 4226 RFC if you want to know exactly how the algorithm behind this works. The way that this is set up is that at registration, a secret string is generated and shared, and I'll talk more about how the sharing happens later, between the service and the user. So there's a secret that is shared at registration time. It never changes, it's never sent over the network again, but it does need to be created and shared at registration time. Then there's a counter. The counter is the number of times that this user has logged in. And so when you log in, they both start at 0. User and server both start at 0. Every successful login, it goes up by 1. You need to know how many digits long the code is going to be. And then there's a hashing function, and this is very well documented in the RFC, and it's implemented the same in everywhere that it is implemented. And the inputs to the hashing function are the secret, which never changes, and the counter, which does change every time. And then we just use a modulo operator to chop off the last 6 digits. So can you see the problem with this, right? If you log in successfully, client and server can increment the counter by 1 every time this happens. If you generate a code and don't use it to log in, they're out of sync. If you try and use 2 clients to log into the same service, you'll get out of sync. And this counter drift problem is really the Achilles heel of hash-based one-time passwords, because there's no recovery from it unless there's some out-of-band way to resynchronize the counters. But it's important to understand, I think, that this is how HOTP works, so we can see how TOTP improves, and the improvement is very small. Well, it's very big in terms of its effect, but the actual change to the algorithm is very small. The counter is replaced, instead of counter sync, we end up with clock sync. So the counter is the current time block. Time blocks are blocks of typically 30 seconds, counting from 1970. So every 30 seconds, the current time block changes. So this counter value changes, the secret never changes again. So every 30 seconds, you get a new value out of this hash. And as long as the server's clock and the client's clock are in sync to within 30 seconds, it's okay, it works. If they're not quite in sync, or perhaps the user's trying to log in just as the block ticks over to the next one, what you can do is calculate the hash for the current time block and the previous time block and let them log in with either. And that's a weakening of security because there are now 2 valid codes, but it's in the name of a more convenient user experience. So it's a trade-off that you might be willing to make. So that is how time-based one-time passwords work, and that's how phone apps work. That's why the code changes every 30 seconds. There's not a lot to it. I mean, the hashing algorithm is, again, different RFC, but really clearly defined. So every app that you can use that generates these passwords will generate the same passwords, sorry, the same 2FA codes at the same time, because they're using the same algorithm with the same inputs. So pro, secure. Con, slightly annoying. I don't know, man, I'm scraping the barrel a bit here. You have to open up the app. You have to like scroll through and find the particular thing. You have to type it without typos. You have to hope that the clock doesn't tick over. It's not that bad, really. It's a small thing to complain about. And this is, I think, the most common form of 2FA user security. Would you like to see some coding about how this can work and how sort of straightforward it is? And you'll get a chance. If you've got a phone with an authenticator app, you should get it out now and get ready to point it at your screen. In case you're doubting my hacking credentials, I too have a balaclava. It's all good. Okay, so I'm going to jump up here and we're looking at my IDE. This is some Java code, and I hope that this code is reminiscent of the code that you saw on the slides a moment ago. We've got a super secret key that needs to be shared. Again, I'll get to that in a moment. You would normally use a library. I'm using this library that's linked up here, which is also linked in the GitHub link that Barry sent out earlier, so you don't need to copy it from this screen. But anyway, there's a secret. There's the current time in hex, which is just generated by the OTP library. And then we call otp.create. We're passing the secret, the counter, the number of digits we want, and we tell it what type, because it can do both. So if I run this code, it's going to generate and print out a 6-digit number. I hope you can all see that. And now this part of the demo can take up to 30 seconds. 819407. Oh no, cool, it's changed, 651511. So the point is this changes every 30 seconds because this changes every 30 seconds. This never changes. Let's see how we get to sharing that with the user. Let's scroll down. Another bit of code, same secret as before, but there is a URL scheme for OTP for sharing these secrets. It's OTP auth : / where you might see HTTP : / in web URLs. This library has a get URL method. You pass in the secret, the number of digits you want, the fact that it's TOTP, and these two strings are the service and the account name on that service, and they are only used for identifying it in the app. They are not part of the hashing algorithm at all. How to share the auth URL with a user. Everyone's favorite thing, QR codes. So I'm going to use the Google Chart API, and then it's going to generate a QR code, and I'm just using string.format to put the auth URL at the end of that. So if I run this, we can see printed down here, there's the OTP auth URL. And if I copy this URL for the QR code, jump over to my browser and paste it in, Google Charts API, don't let me down. What you can do now is, and I'll do the same, and I'll show you my phone as well. I can show you the camera app. I'll use Google Authenticator this time. Add an account from a QR code. You can see I've got a Duke on my desk, and then above that, here's the QR code. Add the account. Right, so I'll leave it up for another couple of seconds, but thank you, Hilma, for that link in chat there. Anyone who's doing this should see the exact same code as me, 970778, and it's about to tick over to the next one. I'll leave it up for another couple of seconds, and I'll show you how we verify this on the server. So the point is, we show this when the user registers, they scan it, it's saved in the app. Okay, ready? I've got 20 something seconds to do this next section. I'm going to run this top class. Again, remember, it's the same secret, and you can see 509384. So I can run this code server side. I can get what the user thinks the code should be from my client side. And if they match, then I know that it's the same, well, it's a person with the same app as registered when I showed them the QR code. So that's how the 2FA apps, the authenticator type apps, where the passcode changes every 30 seconds, that's how they work. TOTP it's I think not that complicated once you understand that it's a hash of a secret and the current time, and the secret is shared when you register by a QR code. And that's all there is to it. I'm going to jump back to my slides now. I said I'm going to jump back to my slides now. I don't know if you saw in the, when I used my camera, then I've got two keyboards in front of me and I just used the wrong one. What's the other most common type of possession factor verification? Push notifications. So you'll be using this if, when you try to log into a website, something just pops up on your phone, says, is this you trying to log in? Your Google account probably does that if you're using the Google Authenticator app. These work differently. Whereas with the one-time passwords, you could use any one-time password app. With push notifications, the service that you're trying to log into will have an arrangement with a service that provides push notification-based authentication, and you will have to have an app that matches that service. If you use Authy as that service, then you can use Twilio's Android or iOS SDKs and receive those push notifications in your own mobile apps if you're developing them. And the point is that you might have to install several different apps to receive these push notifications, even though with one-time passwords, you only needed one. In this case, you might need several, but it's not such a big deal because you don't have to ever use them. They just pop up when necessary. They don't use one-time passwords. They use end-to-end encrypted communication between the service and that's sending the push notification and the app on your phone. And it's essentially a challenge, like, please ask the user if this was them. Yes, it was. No, it wasn't. So imagine if Matt Honan had received a pop-up on his phone. Someone's trying to reset your Gmail password. That was the first thing that happened. Was this you? He presses no, and suddenly, like, the whole first 5 minutes of this talk is, you know, it's not a story. I'd have to find something else to talk about. So secure and easy con, many apps needed. Again, this isn't much of a con. App-based, be it one-time password or if the service supports it, push-based is definitely the way to go in this type of 2FA. So in sort of order that I've been through: SMS, one-time password, push notifications. These account for almost all of the 2FA type logins that I do. What other types of factors? Well, I mentioned earlier inherence. Biometrics is a type of inherence. If you've seen the UK sci-fi sitcom called Red Dwarf, you might remember this episode. If not, spoiler alert, this hand is not attached to a body beyond the elbow. My friend Tef made this, I thought it was funny, joke. Facial biometrics, the password you use as an avatar, and he's indeed got his own face as an avatar there. But actually, you might think, oh, biometrics is not used that often, but I don't know how it is in America, actually, but in Europe, biometric 2FA is used very, very commonly for Android Pay and Apple Pay. So this is mandated by law, at least in Europe, that this has to be done with two-factor authentication. And the two factors are possession, because you have to pay with your phone. So you've got your phone, and you have to unlock your phone to use this. And if you use a PIN, that's a knowledge factor. If you use a fingerprint or Face ID, that's an inherence factor, a biometric factor. And that is considered strong enough that there is actually no upper limit on how much you can spend in one go with Android Pay or Apple Pay, apart from, you know, your own bank balance. What else? Location. That's a factor. It's a kind of inherence. If you have a kiosk which you need to be at to log in and there's physical security around it, then that can be considered a factor for 2FA. Ambient sound. This isn't something I've seen in the wild, but I read a paper proposing that a website could make a sound, some data that's encoded as sound, and your phone's microphone could pick it up, and then they can prove that you've got the possession near the web browser. WebAuthn is a big topic. There's another similar thing called Squirrel, SQRL. WebAuthn is passwordless login for the web. I would encourage you to go to webauthn.guide to read more about it. It's backed by the W3C and a whole bunch of other big companies in an industry body called FIDO. Excuse me. Ooh. And YubiKeys, people often ask about YubiKeys. YubiKeys work in a huge variety of different ways. The typical tiny YubiKeys you get, they don't have batteries, they don't have clocks, so they can't do TOTP, time-based one-time password. Unless they're plugged into a computer, then they can. They have a proprietary solution to the counter drift problem with HOTP, and they sometimes use end-to-end encryption. I don't know a lot about it because a lot of it is proprietary. Okay, so finishing up. It is often said, friends don't let friends write auth. And it's true, right? It can go wrong in subtle and devastating ways. It's tricky to get right. And you should, if at all possible, unless it's really your core business is auth, you should outsource it to someone. And the same goes with two-factor authentication. Again, there are a number of ways it can go wrong. Twilio acquired a company called Authy a few years ago. If you're interested in how Authy can help 2FA, I think it's a very good solution. The Authy app is recommended by the Wirecutter as the best authenticator app. Check out authy.com/whatis2fa. That's all I'll say about that, but I will go back to my sort of mini rant earlier and just say this is our responsibility as industry professionals to stop people like this. Look, I've actually still got my padlock up there, but she's managed to nick someone's, and it's not a joking matter, right? As much as I'm trying to be kind of funny about it, it's a very serious problem. Matt lost some treasured family photos, and other people lose a lot more to these kind of attacks. So together we can work smart and we can make the web a safer place. That is the conclusion of the presentation part of this evening. So thank you very much. I'd be delighted to hear any questions. I'll just put up my contact details on the Birdie website on Twitter and on Twitch there. So feel free to get in touch with me there. If there are no questions, we can move straight on to the workshop part, where I'm going to ask you to implement 2FA on a website. Okay, brilliant. Let's move on. I guess you're all just eager to get their fingers coding. Okay, so let's get rid of that code. Let's close that. So you should have seen this by now. This is a link that was included in the Eventbrite invitation. It's been in chat a couple of times. I'm quite happy to paste it in chat again right now, just for people who might have just arrived and not seen it already. This is the workshop part. And the goal of this workshop is to take an application which only has username and password auth and improve security by adding TOTP 2FA to the user registration and login flows. You'll need these. Hopefully you've all got those. And where to start. There's a command here to clone the repository. If you're cloning it outside of the command line, here's the URL for the repository, but don't forget to switch to the start here tag when you do that. Sounds complicated? Don't worry, there is plenty of help available. I've tried to make it because this is very much more important to me that you understand the conceptual steps involved and see like where in the process these steps fit in, rather than getting bogged down in individual kind of lines of code. There is plenty of help available. 7 files need editing, 100 lines of code, all of which is given in the walkthrough if you need it. And you do not need to create any new classes. So here's details of how to run the app. I'll do that myself quickly. I'm going to just right click on Spring Boot 2FA application and run it. And it will start up on localhost 8080. It will fail if you've got something else running on localhost 8080, but I haven't, I checked. So what next? Go to localhost 8080. Here we go. Right, so here's a website. And you'll need to be logged in to use it. You don't know any login details, so register. Type in a password, MJG123, that's me. I'm going to use PASSWORD and create the account. Hello, thank you for creating your account. And this is the point in the flow where you would see a QR code, okay? Log in. And this is the point where when you're logging in, you would have to put in a code from the Authenticator app. But now I don't have to do that because I'm at the start here tag, password. Log in. There isn't a lot in this app. There's your personal page, and you can see a picture of my dog and boop his nose if you want. And the other thing you can do is log out. There's really not anything there. This is a dummy website, purely to elucidate this point about two-factor authentication. You might disagree with some of the coding style as well. I deliberately tried to make the code as short as possible so that there were less things to be confused about. So back to the README. The app is backed by an in-memory database. Here's the URL to it. And I said there would be a quiz. There is a quiz. The password here is one of the top 5 in the Have I Been Pwned data set. It's also linked in the README if you can't remember. Don't worry. I can connect to this. And the only thing you'll ever want to do in here is click on user DTO to get this select statement up and run it. And you'll see there's the user I've just created. Passwords are hashed. There's a user 123. You could try and guess their password. It is one of the top 5 from Have I Been Pwned if you want to have a go. But yeah, all you'll ever need to do in here is select star from user DTO. You will have to add a new column for the secret to here. Again, I hope it should be clear from the instructions how to do that. How to proceed in this order: user registration flow, user login flow. So I'm going to click on user registration flow. I'm going to stop talking in a minute and let you get on with it. Here's a description of what you need to know. Look at this tag. Well, I wouldn't recommend looking at that tag. That's where the finished code is. What I would recommend doing is firstly looking for lines that are marked with to-do registration and just see if you can sort of see where they are. And then there's this walkthrough section. And for this is literally everything you need to do to get this. And for every step in here, I've provided a finished code link, which literally takes you to a link with the code. And if you wanted to do this without typing anything into your IDE, you could just copy and paste it all. Like I say, the goal here for me is that you understand the process and see how to fit it into an app, not get stuck wondering how to add dependencies to Maven or whatever. So with that, I'm going to stop talking for a moment and let you get on with the first part. And I would love to take questions. I'm going to be asking from time to time how you're getting on. And I will say in about 20 to 30 minutes from now, I will go through the code changes. And frankly, what I'm going to do is take stuff from the finished code. So if you feel you want to do that, don't be shy. You know, it's not a problem at all. So please, you know, enjoy.
We've trimmed about 40 minutes from this video where live participants were working on a series of exercises. You can pause the video and try the exercises, or continue the video to see the rest of Matthew's presentation.
Okay, so as we were starting from the end of the previous one, I'm not going to change any of the code that's there. I'm just going to start from here. So add a field to the login page, login HTML, for the user to provide a code from their app. Finished code. Well, you know, I might actually take this a bit more seriously and not do just copying and pasting. Let's go to the login page. There were already two fields. There's a username and a password. So how difficult, well, I am going to do copying and pasting, but from a different place. How difficult do you think it's going to be to add a third one? Let's call it 2FA code. We use that 4 has to match this ID. This name is what it will be called when it reaches the server side. And type equals password means it's going to be like starred out, and we don't really need that. So let's change this back to text. Okay, done. What's next? That's about what I did, isn't it? Get the user provided 2FA code from the HTTP servlet request. This is a slightly complicated step in the custom authentication details class. So up here, custom authentication details. This gives us a chance to pull anything else out of the HTTP servlet request that we need for authentication, which we know is the code from the user. So we got the request. Get parameter is how I'm going to get that out. Get parameter, yeah. And this name has to match the name that I gave this here. So it's going to be 2FA code. What we need to do is, of course, the call to super has to be first. What we're going to do is store this in a field. So private. There we go. Control Alt F was my keyboard shortcut for that to extract as a field. And it's private, it's final, that's cool. It's cool to be final. I like final things. I like immutable, you know, data in general because it's easier to sort of reason about, but it can't be private and still be read unless we had a getter. So get, oh, it's called parameter. That's a silly name. Let's call it, unfortunately, we can't call it 2FA. Oops, sorry. Unfortunately, we can't call it 2FA code because I don't think we can, yeah, we can't start variable names with a number in Java. So we'll just call it 2FA code like that. And then down here, let's get to, just get 2FA code. I just said we're going to spell the number out. Okay, that's what we need there. In the custom authentication provider class, generate a 2FA code based on the user's secret on the server using otp.create. Let's try and do this right. So in the custom authentication provider, authentication.getName is the name of the user that's trying to log in. So let's grab that. I'll do it all below these this bunch of comments. Let's grab that. Authentication.getName, and we need to look that up in a user repository, which is to say look it up in the database. So we'll just uncomment that auto-wired thing there. And so user repository.get find by username, that's what it's called. And this needs to be stored in a variable. I'll call it user DTO. It's possible that user DTO is null if someone's trying to log in with a username that doesn't exist. So if goodness me, if user DTO is not null, then we'll do our stuff. What will we do? We will, rather than waste your time, I will actually have a look at the finished code here, and I hope that that's what you did as well. otp.create, yeah, of course. otp.create, the secret, we know we've got a user DTO, we know they must have a secret, and we know we can get it off of the user DTO. What are the other parameters here? Base, that's a slightly confusing parameter name, but I happen to know that means it needs OTP time in hex. Now, I don't know why this thinks it can throw an exception, because all it's doing is system current time millis. So it's a checked exception, so we'll have to deal with it. What are the other parameters? Number of digits, we know that's 6, and the type we know is type dot top, top of the pops. So this is our server code. So I have to deal with this exception. Now, what is the right thing to do with this exception? Well, add it to the catch block, obviously, but let's just wrap all those into one, so we don't need that. What's the right thing to do in terms of the app's behavior here? Well, the fact is that we cannot verify the user here. So we are going to throw an exception. We're going to throw an authentication exception, because that's what we do when we don't want them to log in. We can't let them log in because we haven't verified that it's them. Authentication exception itself is abstract. So let's throw a new, and there's one authentication service exception, couldn't generate. I'm going through this code. This is the longest bit of code, so I'm just going through this in a bit more detail about why I made the choices that I did. Hopefully the rest of it was fairly self-explanatory. Couldn't generate OTP code, user can't log in. I would recommend logging that as well, but I'm not going to for this purpose. Okay, so we've got that string. So the user code is is from this object here. This gives us our custom authentication details object, which remember we grabbed the field from the HTTP servlet request, and we'll do get 2FA code from that once we put the right number of brackets around the cast. So now we've got a server code and a user code. So if they're not equal, like, it's the wrong code. It's like, it's as simple as it sounds, I think. If let's say when I'm doing a dot equals comparison, I'm always aware that dot equals is not quite symmetric, in the sense that you're calling one object and passing the other object in. So which one can be null, which one is more likely to be null, affects the order that you do it. That's why you'll sometimes see me do, like, if that equals like my string. That seems to me to be safer than doing my string dot equals quote quote, because this also caters for the fact that my string might be null. So when I do this equals check here, which one am I going to do it on? I guess server code is never going to be null, because it's always come from here, right? So server code dot equals user code. If that is not the case, then we'll throw a new bad credentials exception. Get out of here, right? I think that's all we need to do. I mean, hopefully that matches this. Yeah, oh, I log them here. I do the same. Well, I've done things in a slightly different order, and I've logged that. Oh no, I hope your logging your logging strategies are a little bit better than that. So what now? Done. That's all we need. So I'm going to come here. I'm going to restart the server. I'm going to, like, fingers crossed that it starts up and I haven't messed it up in some silly way. Looks good to me. Yes. Okay. So let's go back to my own page. I'm not logged in anymore because the server's bounced. Let's bring my phone back in, unlock it. Let's see a few things, notifications from Twitter most likely. So register here and let's see this flow work. MJG123, password, create account. Hello, this is a, that's okay. I think I can scan, I think I used different. Yeah, Spring Boot 2FA demo is this one. So it's this one, 008802. It's actually a bug on my screen, excuse me. Now you understand as well why the clocks on all of these are in sync, because there's nothing to do with the age of the account there, right? It's just the time in blocks of 30 seconds. So it's going to be the same for all your accounts. So let's log in. MJG123, password PASSWORD, and my code. And I'll just type it wrong just to see what happens. 056. Oh, well, I'll tell you what, 598. Oh, no, it's changed and I've tried to log in. I guess my computer clock is slightly able to cope with that. Log in again. Password. So if I get the code completely wrong, just mash the keyboard. It's going to prevent me from logging in. I haven't like surfaced any kind of error to the user here, the human behind the other side of the screen. It just you know, that's an optional extra. I guess you could go and do that if you want. 817226. Log in. Right, brilliant. I'm happy about that because I get to click on my dog's nose again. So that was it. That was the full extent of the 2FA part of this. However, there was an extra credit section, if you remember. And so let's look at that now. And I'm quite happy to look through that together with you. I'll just get rid of my phone from the screen. We don't need that, do we? So where were we? We finished with this. We finished with that. We don't need to look in the database. Everything's working. So I hope you've all managed to get to the end. If anyone is like dying to tell me to stop before we move on to integrating Have I Been Pwned, then please use this opportunity in the next 5 seconds. Nothing. Okay. Well, that's a resounding vote of confidence in carrying on then, as far as I can tell. So let's see how to do that. A couple of code changes, and we'll need to add a library. So first of all, and this one's a little bit less like hand-holdy, so we're going to have to do a little bit of research ourselves. Let's grab Have I Been Pwned API, and I tested this one. It seems very good. It seems perfectly acceptable. So into the pom.xml. Yeah, next to the OTP one, let's put HIBP one. Don't forget to click that little thing there, or do what key promoter X is telling you, Control-Shift-O. What next? In web security config, create a new factory method for creating, oh yes, that's right, we have to create instances of this client, and I found it convenient to create them as Spring Beans in the web security config because I've created another couple of Spring Beans down here. Web security config is a configuration class. It defines all of like the paths, who's allowed to access them. So for these are permit all, anything else needs authentication. It defines how Spring deals with the login flow, tells it to use those custom authentication details that deal with the HTTP servlet request, tells you what to do, and it's like that. So if you're at all interested in Spring Security, check out, this is like the main bit of configuring Spring Security. But also down here, I'm going to put anything that I think is security related. You need to provide a unique identifier for your client that talks to this API. Add padding, I'll talk about what add padding does in a moment. And then we just build a client and it's got this class. And because this is registered as a Spring Bean, we can hop over to the web controller, and people who like skinny controllers will be cursing me. Malcolm, thank you for coming. I'm glad you were able to get something out of it. Sorry you have to leave early, but no problem. People got to live their lives. Glad you could make it. Up here, I'm going to auto wire private, and this was a How I've Been Pwned API. What was it? Why can't I remember that class name? Or why can't IntelliJ? Maybe I typoed it. Okay, and down in user registration, register new user. So this is where we get a chance to reject people who are trying to register with already existing usernames. And so this is the right place to also be rejecting people who are using terrible, 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 terrible passwords. So I wrapped up the calling of this to a private method, and I'll paste it in and then go through in detail what it's doing, right? We need to import that. We need to import that. This was a fun bit of code to write. I really like using the Streams API. Any chance I get, I jump on it. So we're going to take a password and we're going to return how many times it's in the Have I Been Pwned website, right? So the way this API works is very interesting to prevent people sending plain text passwords or like, any amount of passwords across the internet. It works like this. You hash the password. You submit a request saying, please give me back all the hashes of passwords in your database and the count of that many of the number of times that hash appears, and you submit the first 5 characters. So it gives you back an awful lot of results. And you submit the first 5 characters and it gives you back a list of everything that could follow those first 5 and how many times it appears in the database, right? So this means that you don't send the password, you don't even send a hash of the full password, and that add padding equals true, which I mentioned from down here, means that sometimes it will just include a whole bunch of other things that have 0 hits just to make the response bigger, or so that actually you can't even tell by observing the size of requests and responses what kind of password might be looked for. So it's really like obfuscating and taking good care over this. So what we get back is a list of pwned hash objects, where a pwned hash is literally a hash and the number of times it's in the database. So we get back a list of those. I'm going to stream through it. I'm going to filter where the hash in the object is equal to the rest, i.e. like all but the first 5 characters of that. Find the first. This is an optional because there might not be one. So with an optional, what I'll do is I'll map to just get the count out of it. And if it's not there, I'll return 0. So I thought this was a really good sort of, like this, well, not my code's good, but the Streams API made this code a pleasure to write is what I'm trying to say. Okay, so what we need to do is just call this in here. So how have I done that? Literally like that. This throws a checked exception, remember? So we just need to add that to there. So we get the password from the user DTO, and this means at this point we're getting it basically from what they've typed in on the page. It hasn't gone into the database yet. We get the count of the number of times that appears in the Have I Been Pwned API, and store that as an int. And if it's greater than 0, reject. And this is a Spring MVC thing that you can have a binding result, a binding result injected into your methods, and you can reject individual values. I find it a bit weird to get used to at first, but actually it works very smoothly in cases like this, so I'm happy with it now. So we're going to reject the password, and we're going to provide a key, which is actually looked up in messages.properties. So we need something in here. I was expecting it to be there for some reason. It shouldn't have been. And it's not mentioned here as well, so it's like an Easter egg. That is something I'll need to add. But it looks like this. Tags, have I been pwned, source, main, resources, messages.properties, password overused. It's funny that GitHub thinks that's a comment when it's not. Okay, so let me just make that a little smaller so we can read it carefully. Password.overused, that's the name of the key. Whoa, don't move that. That's the name of the key, which I'm providing here, password.overused. The field that it can apply to is user.password, and then you can use placeholders like this. This password has already seen, it's not seen 0 times, that's a placeholder. And you provide things to go into those placeholders in an array there. And then because I don't want to tell them they've registered, I'm going to send them back to the registration page. So that should be enough. If I bounce this server again, fingers crossed. Yeah, looks good. Let's just snip that off the end of the URL. Register here. Oh yeah, the same old MJD123 PASSWORD. No. So this is an example of a, you know, obviously what Paul did with Co-op Digital is much more kind of involved, and they had some tests, for example. But this is an example of how kind of it isn't as complicated as you might think it is to introduce better security. And I will recap my rant from earlier, maybe just to say, like, this is our responsibility as industry professionals. It is not users' responsibility, you know, that to do this kind of thing, and like expecting them to do it is a mistake, because time and time again we've shown that they won't. So helping users to have better security by preventing them from using common passwords, by enforcing 2FA, is a brilliant thing that we can do to help users' security and protect ourselves, you know, from the legal liability that there might be for exposing users' data, but also like to fulfill our ethical obligation to our users to do what we're promising, which is to look after their data for them. I think at this point, I'm going to ask if there are any further questions. And if not, I'm going to say that that's a wrap, and I will hand it back over to the NYJavaSIG crew.
Thank you, Matthew. For those of you watching this video, our next meeting will be about Project Loom with speaker Ron Pressler. Please join us then.